Okay, the continuation. Then the part, the force is already there from the equation G. Already we cases also we discussed. That is G into M1 M2 by R square. That is equation 1. And that is equation 1. And already we know that F equal to mg is also another force. So by equalizing both, because this is the F, this is the F force. So by equalizing the forces, then G into M1 M2 by R square equal to mg. Okay, here the case one. Here we taken a case one. We discussing that here we taken Earth. That is an isolated body. That is a very high massive. We know that. So considering that mass is very big, so that it is not enough to maintain only m1 small m to denote small m. So I can denote that m1 will be the value of m, capital M. Okay, here in capital M. Then this m2 we taken there is stone only, right? So comparing with the mass of the earth, the mass of the stone will be very less. So I taken that is a small m. Okay, then the radius, then the distance between the stone is, this is the earth, and the distance between the stone is here only, the stone is just here only. So that is just on the earth surface only. So that I taken the distance as from the center to uh, the surface of the earth. So it is very high. We know that. So that is I taken that is a capital R, that is very high to compare to given the importance only. I given the capital. Okay, that is capital R. Then that small r equal to the distance equal to capital R. Then finally I substituting these equations. That is G into M1 is capital M, and small M2 is the mass of the stone, that is small m, by R is capital R, that is R square, that equal to, already this is mg. Okay, mg, the stone, the weight of the stone, right? The weight of the stone, that is m I taken. So that m and the gravity G, mg, equalizing those two. So here this m and m is equal, so that I just cancel. Then finally I got G capital M by R square equal to G. So finally I found that G equal to G. I'm just reversing this LHS and RHS only. Clear? For our convenience. Okay. G equal to G capital M by R square. So this is the final equation and relationship between acceleration due to gravity of a particular body. But that means that's a big body, right? So acceleration due to the gravity of that particular body and the universal gravitational constant, and then and of course the mass of the big body, and the distance of the distance, that is radius, that's maybe distance from the distance between two bodies, right? So this is the mainly, this is the relationship between gravitational constant, acceleration due to gravity, and gravitational constant, and universal gravitational constant, right? So the value of G is, already we know that, already the value of G is 9.8 meter per second. Clear? So that is the value of G. So let's we discuss some problems and some questions based on this. Okay, I think this concept is clear to you. This is a special cases. Clear? You remember that this is the case, some conditions only. This is the continuation. This is just conditions. Because of this electrical pen, I may can't easy to write here, so that I'm indicating. Uh, This is the continuation. Yeah. Then next. So we know that gravitational force is the most weakest. Okay, the gravitational force is weakest. That is one way given here. The gravitational force is weakest, and attractive force existing between two protons inside the nucleus is known as two protons. And also we will discuss about the electromagnetic force and properties right now, right? Shall we discuss that? Okay. Yeah, electromagnetic force. What is this electromagnetic force? What is the electromagnetic force? This is the second force. This is second force in our categorization, right? Okay. That is the electromagnetic force. So electromagnetic force is a that is a dominant that is dominant at the atomic level. That is dominant at atomic level. It is already we discussed the atomic structure and all those. So a dominant force at atomic level, and is which is responsible to holding the atoms together, to holding the atoms together. This is atom one and this is atom two, to holding the atoms together, to holding the atoms together to make up the molecules. So because we know that by atoms together to give a molecules, right? By the number of atoms, it should be a molecule. So this is the so electromagnetic force is a dominant in atomic level, which is causes due to atoms together, then it will be form a molecule. Are you understand? Clearly. Once again, electromagnetic force is a that is a dominant force. That is a dominant force. That is a dominant force, which is useful, which is responsible to atoms together, atoms together, which is then because of these atoms together, because of these atoms together to make it will be togetherness of these atoms, it becomes that is a molecule, right? Together of these atoms, it will be a molecule. Clear? Is a molecule. So these electromagnetic forces useful to formation of molecule. These electromagnetic forces useful to make a molecule to formation of molecule by togetherness of atoms. Clear? By togetherness of atoms. So that is because of the electromagnetic force it will be possible, and also it also binds it also binds the electrons of an atom to the nucleus. The electrons in the electrons of an atom, the electrons of an atom to the nucleus should be can be electrons can be binded in the atom only, right? Electrons. This is the electrons. We know that this is the main important for the electrons. What the electrons we know the electrons are revolving around the nucleus. These to binding the electrons. into the atom only, into the atom only. This electromagnetic force is very useful. Clear? So it also binds the electrons of an atom in the nucleus only. To the nucleus only. Nucleus ki bind అయ్యేటట్లుగా ఉండాలి. ఈ ఎలక్ట్రాన్స్ న్యూక్లియస్ కి అనుసంధానంగా ఉండేటట్లుగా electrons ఉండేటట్లుగా this electromagnetic force is useful. The electromagnetic force is useful to that particular electrons to be bound to the nucleus in to be in the atom only, to be in the atom only also. Clear? Next, it is either attractive or repulsive force. This is either it is the both. It is a both attractive force and also a repulsive force also. Attractive and also a repulsive. Repulsive. Also a repulsive force also. Repulsive force also. It is also a long range force. It is also a very long range force. It is a very long range force. Here it is a very long range force. Like this, it is also a very long range. This force is between each and every molecule. Then only it will be stable. So that it is a very long range force. Clear? And it is communicated through photons. It is communicated through photons. Clear? It is communicated through electromagnetic force, can be communicated through photons. Next, that is about the electromagnetic force and its properties. As we discuss about strong nuclear forces, strong nuclear force, strong nuclear forces. So, what is this strong nuclear forces is? This force may act between pair of nucleons, that is between protons and neutrons. Already nucleons, what is the nucleons? Nucleons. Clear? What is this nucleons? The nucleons are, which is in the nucleus? This is the nucleus. Okay, this is the nucleus. In the nucleus, there is a protons and neutrons. Protons and neutrons. Right? There is some protons and neutrons. Already we know that. So this is the force. These strong nuclear forces. These strong nuclear forces acts between pair of nucleons. Between the pair of nucleons. Between the pair of nucleons. What are the nucleons? Between the protons and neutrons. Between the protons and neutrons. That is between protons and neutrons. Clear? Protons and neutrons. So that means there is a force, the strong nuclear forces between this proton and this neutron. Clear? So this proton and neutron, there is some strong nuclear forces, so that only this can be bounded. So this strong nuclear force is responsible for the force acts between the proton and neutron. These proton and neutron, already we know that these are known as nucleons. Right? I think you understood. So these are charge independent. First character properties. First property, these are charge independent. Why I said this is charge independent when means you can observe by the explanation before. That is, it is the acts between the nucleons. Nucleons means I said proton and neutron. Here the proton is a positive charge and neutron is a nucleus charge, no charge. But still now they are connected because of this force, right? So that means positive is this, it may be charge. So positive and negative, it may be attraction force, but it is acts between the positive and neutral charge. So that this is a charge independent, I said. Next one. It is a spin independent. It is a spin independent. It is spin independent. Next. It is a short range force. It is a very short range force. Clear? It is a very strong, short range force. Why? Because in the nucleus is very small. In there, in there between the nucleons, so it's a very little distance. It only acts between the very little distance, right? So that those are very strong, short range forces. So that is about strong nuclear forces. Here, next. Next, weak nuclear forces. Weak nuclear forces. Weak nuclear forces. So these weak nuclear forces are, so these weak nuclear forces are responsible 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 for a type of radioactive decay, for the type of radioactive decay. Here, responsible for radioactive decay, that is known as beta decay. We know that alpha decay, alpha scattering, and gamma scattering, like this. This is a beta decay type of radioactive decay. That means it can emission. Decay means it can emission. So these weak nuclear forces is responsible for the beta decay, that is radioactive decay, that is radioactive radioactivation, radio elements can be removed from there. So radioactive decay. Okay. So and these properties for these, so properties for this radioactive decay, properties for this radioactive decay is, it is a very short range process. It is also like a strong nuclear forces. It is also a very It is also very short range force. It is also very short range. It is also very short range force. Next, it is communicated through. It is communicated through weak force. It is communicated. It is communicated through weak bosons. Bosons are also one of the particles, like a neutron, proton, nucleus, electron. Like a boson is also one of the one of the fundamental particles. So like a bosons, it is communicated. Clear? It is radioactive decay. We communicated through bosons. Clear? This is about complete about the forces. Of course, you can learn about these electromagnetic force and strong nuclear forces and weak nuclear forces in your further future, like intermediate level, like that. Okay, but as per introduction, I'm telling you because I'm discussing about the IIT material of ninth class. Next, again, I'm telling, asking. Already we discussed. There is one question: radioactive decay exists due to. Why? Radioactive decay, why it exists? Radioactive decay exists due to, why? Weak nuclear forces, right? Because of weak because of weak nuclear force. Next, there is one question that two brass balls, there is a two brass balls B1 and B2. There is two brass balls. First one is 2 kgs and second one is 5 kgs. Experiences a force of attraction of in both there is a force experience that is 2 newtons when the distance between their centers is doubled. If if the distance between these two balls is doubled, distance between the two forces is double the force of the attraction is. So still now it is 2 newtons. If the distance between the two balls is doubled, what will be the force? Already we know the formula F equal to G m1 m2 by r square. Clear? Similarly, if r becomes, that is what is said, if the distance between the two balls is doubled, that is here r becomes 2r, right? R becomes 2R. So if the force F G M1 M2 by, if R is doubled, that is it doubled into 2R. R is become 2R. So then 2R square, that is equal to, then that is G M1 M2 by this 2 will be 4R square, that is equal to G M1 M2 by R square, 1 by 4 into G M1 M2 by R square. So it is nothing but a 1 by 4 into, if you consider this G M1 M2 R square is nothing but a this F, right? So that is 1 by R into F. So finally, the initial force to the final force, what happens? That is, if the distance is doubled, the distance is 2 times, is doubled, then the force will what happens? Then the force will be 1 by 4th of before force. That is, if the force, that is, if the force is given here is, first initially the force is given is 2 newtons, right? I am just, as per our convenience, units should be, I just given a small, with a small quantity. So that is 2 newtons is given. Now the new force will be by 4th of initial force. That is 2 by 4th. So which is 2 by 4th is nothing but a 0.5 newtons. Then the new force is, and the new force between these two bodies is nothing but a 0.5 newtons. I think you understood the problem. Again, I will clearly explain you with a fresh page. If there is two balls, there is a first ball is which has 2 kgs, and second ball is which is a 5 kgs. Of course, with the mass, we may not. There is no need of mass, but they given information. So the distance between the two masses is r. If the r is doubled, if r is doubled at initial, at the distance of r, the force is given. That force is nothing but, the force is nothing but 2 newtons. Okay, now r is doubled. So r will be doubled. That is r is 2r. Then what is the new force? Now he asked it, right? So already we have a formula F equal to G M1 M2 by R square. We have a condition R is double. That means R will be becomes 2R. Then F equal to G into M1 M2 by 2R whole square. Right? Then F equal to G M1 M2 by 4R square. Now I'm writing it here. So then F equal to 1 by 4th of G M1 M2 by R square. That is F equal to 1 by 4th of, already we have F equal to G into M1 M2 by R square. That is initial one. So now the new force is, I just kept here. This is the new force. Here, this is the new force. Okay. When R is 2R, then it is new force. The new force is the old force 1 by 4th into this G M1 M2 by R square will be there. So that, so now F new force is, what is the new force you asked, right here? So old force is 2N. So old force is 2N, 1 by 4 into 2 newtons. So that is a units. That is nothing but a 2 by 4 newtons. That is nothing but a 0.5 newtons. So and the new force is 0.5 newtons when the distance is doubled. Clear? Let's move on to the next one. Yes. Next one. The gravitational force between two bodies is F. The gravitational force between two bodies is capital F. If the mass of each body is doubled now, the mass of each body, this is M1 and M2, but the new masses will be double 2M1 and 2M2, 2M2. The mass of each body is double, and the distance between them is halved. The distance between them, that is R, the distance between them is halved, that is R by 2. The distance between two is halved. Then the force between them will be, then what is the force between them now? So according to the equation, already we have the solution. Already we have F equal to G M1 M2 by R square, right? That is F equal to, now I'm substituting the new values, that is Fn, F1, that is G into G is constant. So instead of M1, it is doubled, that is 2M1, that is 2M1 into M2, that is 2M2, and R will be halved, that is nothing but, that means 1 by 2 halved. Okay, that is halved, halved. Okay, so that is R by 2 whole square. Then that is this 2 into 2 is 4. Fn equal to 2 into 2 is 4. That is 4 G M1 M2, right? 2 into 2 is 2 into 2. 1 minute. This 2 into this 2. I will with another color. Here, here. this 2 into this 2 gives this 4. And this G will be here, this G. This M1 will be here, this M1. This M2 will be this M2 here, right? By this R square by 2 square, that is 4. So this is given. Now this 4 will be moving to the numerator, that equal to, this 4 will be moving towards the new numerator, that is 4 into 4 G into M1 M2 by R square. That is nothing but this is a new force, Fn Fn. So now 4 into 4, that is 16 G M1 M2 by R square. So already we know that this G M1 M2 by R square is Fn equal to, already we know this G M1 M2 by R square is nothing but this main F, right? F into G into M1 M2 whole square. Sorry, F into G M1 M2 by R square. That is not so. I can be rewrite that is 16F. So that finally, what is the new force compared to the old force? That is 16 times of force. That means when I implemented, the first mass is doubled, and second mass is also doubled, and the distance is halved. So then it will, the new force will become 16 times of the old force. This is the final answer. So next, the new force is 16 times of old force. 16 up. Very clear. Next. Okay, let's do eliminate next problem. The acceleration due to gravity at the surface of the moon is. So already we know the acceleration due to gravity on the Earth is 9.8 meter per second, right? And now, according to the problem, given that the acceleration due to gravity at the surface of the moon, the surface of the moon, that is surface of the moon at the acceleration of gravity is given that 1.67, 1.67 meter per second square, meter per second square is the radius of the moon. In the same way, if the radius of moon is 1.74 into 10 power 6, 10 power 6 meters, okay, then find the mass of the moon. అలా అయితే, if it is possible, then find the mass of the moon. What is the mass of the moon? So by calculating this, Yeah. Nice one. The accelerated gravitational surface of the moon is 1.67. And if radius of the moon is, then find the mass of the moon. It will be the force. Do you understand what is the formula you can use? Can you use? We have a relation. Already we have a relation. We just observe that. We got the relation. Already we have equation. That is G equal to acceleration due to gravity. G equal to F R square by G M. Sorry. Yeah. That is that is G equal to G M by R square. We have this equation, right? That is according to G.